Hello everybody. We're going to start with one example from the Aardvark Sinusoid handout, which is homework, and then I'll go backwards in the student note packet and get into the writing equations. So I'm starting on page 29, and I'm just going to walk you through example 1. It's been a while since you guys have done this, since there was a break, so I just want to remind you guys how to graph sine and cosine, and then we'll get into the writing equations lecture. So number 1 on page 29 looks like this. We're going to fill out all of the information, and then we're going to graph this curve. We've got negative 2 times the cosine of 4x minus 2 pi over 3 plus 3. So one thing we're going to note here is we're in radians because the variable is x and not theta. And the first thing I'm going to do is I'm going to rewrite this equation so that we've got the frequency pulled out, or the coefficient of x is 1, so I can get the phase shift correct as I go and identify other things. So that negative 2 is going to just stay on the outside. But here, I'm going to factor a 4 out of both of the terms on the inside, so that way the coefficient of x is positive 1 instead of having that 4 next to the x. So when I factor a 4 out of that 2 pi over 3, essentially I'm dividing by 4. So that's going to become 2 pi over 12, which is pi over 6. So that's going to be the correct phase shift, and then that plus 3 is just still sitting on the outside. So remember that plus 3 is that vertical shift. We're going to represent that as the equation y is equal to 3 because it's the horizontal line we will sketch with a dotted line. The amplitude here is the number in front of cosine. We take the absolute value, so it's just 2. That negative is going to represent the reflection that we'll graph. Our max comes from taking the sinusoidal shift and adding the amplitude, so that's going to be 5. Our minimum is going to be the shift minus the amplitude, and that's 1. So we're in all positive values here. Our frequency is 4, the number in front of x. The period here then is 2 pi, our standard period divided by the frequency. So our period here is pi over 2. The subinterval length is the period divided by 4. So that is going to be pi over 8. That's what we're going to count by along the x-axis. Our phase shift, we're going to represent that as left or right, a certain value. We're going right pi over 6. So when I write the phase shift, I'm going to represent that as plus pi over 6. We're starting at pi over 6. It's positive pi over 6, so I'm going to put that plus sign there. The plus sign doesn't really matter. If it's negative, though, make sure you include the negative. All right, our first 5 key points, I'm going to set up the ordered pairs first, and then I'll start filling in the y values. Now we're graphing the reflection of cosine. So the reflection of cosine has the ordered, the key points in this order. Cosine, the reflection, is going to start at its minimum, hit its axis, then go to its max, axis, and then end back at the minimum. That is the reflection of cosine. So the minimum here we found was 1. The sinusoidal axis sits at 3. Our max is 5, back to 3, and we end back at 1 for that reflection. Now we're going to always start that first key point at the phase shift. So we're starting at pi over 6. And remember that we are counting by pi over 8. We're counting by that subinterval. So the next key point needs to be pi over 6 plus pi over 8. So I need to find a common denominator here so that I can add these two things together. So remember that this is the phase shift, and then this is the subinterval length, and that's how we're going to count along the x-axis, always starting at the phase shift, adding that subinterval length. All right, I think the common denominator here is going to be 24. So this is going to be 4 pi over 24 plus 3 pi over 24. That's going to give us a total of 7 pi's over 24 for our next key point. And then to that, I'm going to add another 3 pi over 24, which gets me to 10 pi over 24, which is 5 pi over 12. Okay, that was 10 pi over 24. Add another 3 pi over 24 to get 13 pi's over 24. Add another 3 to that, we get 16 pi's over 24, which is going to be 2 pi's over 3. Right, so those are the first 5 key points, but we're going to make sure that we hit all the key points to give us 2 full cycles along the x-axis, including at least 1 point to the left of the y-axis. So let's scale these axes, and then we'll sketch our curve. I'm going to drop the x-axis pretty low because we have only positive values for our cosine curve, given our minimum is positive 1. I'm not going to put the y-axis in until I have fully scaled the x-axis first. Because we've got that phase shift, I'm not entirely sure where that y-axis is going to hit. So we want to make sure that we draw that in last after we've scaled everything. All right, so our phase shift is pi over 6. That's what we're going to start with. And I'm going to go every 3 tick marks is a new key point. So here I'm going to add pi over 8. That gets us to that 7 pi's over 24. And then we had 5 pi over 12, and then we had 13 pi's over 24, and then we had 2 pi's over 3. Now remember that that's 1 full cycle. We need at least 2. So I'm going to keep going here. So that 2 pi over 3, that was 16 pi's over 24. So then I'm going to count this as 19 pi's over 24. I'm just adding 3 to the numerator. And then this is going to be 21 pi's over 24, which will simplify to 11 pi's over 2. I mean 11 pi's over 12. Okay, that is as far as I can go in the positive x direction. So I'm going to go backwards to make sure that I get that negative key point as well. So from pi over 6, now I actually have to subtract pi over 8. Or I have to subtract 3 pi's over 24. So if I go backwards, that is going to leave me with a single pi over 24. And then I'm going to subtract another 3 pi's over 24. That's going to get me negative 2 pi's over 24, which will simplify to negative pi over 12. And then I can fit one more. That's going to get me to negative 5 pi's over 24. So really important that you guys can count by radians. You're good with adding those fractions in there as well. Okay, now we can proceed with graphing the y-axis. Now, the y-axis is when x is 0. So the y-axis is going to live somewhere between these two things. Just make sure that you graph it appropriately. Just so happens in this case that 0 would be this tick mark right here. So I'm going to drop the y-axis right there. And then along the y-axis, I only need to mark the min and the max. That is the minimum. If you want to do more, the sinusoidal axis is fine, but the min and the max are all I really need to see here. So I think I'm going to count by, let's see, 1, 2, 3, 4, 5. Count by 0.5. So that's 1, that's 3, that's 5. Those are all the important pieces of this graph. And I'm just going to sketch the curve now. So sinusoidal axis sits at the line y is equal to 3. There's my dotted line. That's going to give me my sinusoidal axis. And then we always start at the phase shift. So remember, we're graphing the reflection of cosine. At the phase shift, which is pi over 6, the reflection of cosine sits at its minimum. And then every new key point will follow the pattern of negative cosine. So we start at min, axis max, axis min, axis max. And then going backwards, if at pi over 6, we're at a minimum, at pi over 24, we're going back to the axis, negative pi over 12, we're going to the max, and then back to the axis here. We're just going to sketch the curve, smooth, continuous curve, no V's, and there's a refresher on how to graph cosine or sine curves. There's my curve. Make sure that you guys go through both of the endpoints. These are periodic functions. They go on forever and ever in the positive and negative x direction. So we want to make sure we go through those endpoints to represent that. Okay, so you guys are going to finish up the rest of those graphs in the Aardvark sinusoid handout. That's on pages 29 and 30. But we're going to the more important piece of this lecture today, which is going to start on page 26, all about writing equations of sines. We're also going to use one of the chapter 6 handouts that wasn't in your note packet that I asked you guys to print out separately. So if you can take a second to find the page that looks like this. It's the same on the front and the back. One is just in radians and one is in degrees. This is going to be really helpful in how we set up the kind of template to write an equation of a sine or cosine curve. Okay, so before I get into how we're going to do this, A couple of things to note here that are really important. The majority of your points on the test for this unit are going to come from a couple of questions that ask you guys to write the equation of a sine graph. So this lecture is super, super important. I'm going to walk through 2 examples with you and then have you do 2 on your own before you start in on the homework problems. But please check your work. Be really careful about checking your answers on the homework pages on page 27 of the student note packet. And if you have any questions, please come to office hours so we can get those addressed, because these are tricky problems, but they're going to be worth a lot on the test. So really important that you guys understand them and how to work through them. Okay, so on this template, this is what we're going to do, and you guys are going to do this for your homework as well. For each of these curves, we're going to write both an equation for sine and cosine. So I need to see 2 equations, and I need you guys to show all of your work, and there should be quite a bit of it. So make sure that you guys are following along with this lecture and you're doing those homework problems the same way, or you're not going to get full credit. You're also not going to get credit on the test. The first thing we're going to do, we're just going to follow these steps. And this is a perfect example of a handout to have next to you guys as you take the test. So step number 1 is we're going to set up a template. And we're going to do this twice. 1 for cosine, 1 for sine. We're going to leave all of these spaces blank. So we're going to leave a blank for the amplitude, and then we'll write our cosine or sine curve. Then we're going to place a blank for the frequency. And then on the inside, plus or minus a phase shift. And then lastly, that sinusoidal axis or the vertical shift going on there. So 4 blank spaces we're going to leave in our templates for 1 cosine, 1 sine curve. And then we're going to work through the rest of these steps to kind of fill in those blanks. So the first thing we got to do is we can find the amplitude. This one is probably one of the easier steps. Remember that the amplitude is half the total height of the graph. So given whatever information we've got, and that will change based on the graph, just figure out what the amplitude is, and we're going to just fill in that first blank with whatever amplitude we find. The second step, after we've set up the template, which is step number 3 in this case, we're going to find that axis shift, that vertical shift. Again, one of those easier things to identify is the phase shift and the frequencies that get a little bit trickier. So finding the sinusoidal axis, take the max, subtract the amplitude, or take the minimum and add the amplitude, or take the max and the min and divide by 2. Different ways that we can find that sinusoidal axis. Figure out which you prefer, and then stick with that. Step number 4 is where it gets a little bit tricky. So there's different parts to step 4. The first thing we're going to do is we're going to find the sub-interval length. We're going to see what information we've got, what values on the x-axis we have, and then we're going to count how many sub-intervals we've got in that interval, and that's how we're going to find the sub-interval length. We'll take the biggest number on that x-axis, subtract the smallest number, and then divide by the number of sections between our key points. That's going to give us the sub-interval length. Once we've got that, we can multiply that number by 4 in order to get to the period, which is step B on step number 4. And then once we've got that period, we can find the frequency by taking 360 or 2 pi and dividing by the period. All right, last thing we're going to do is we're going to decide what type of equation we're writing. So do we want a positive cosine curve or a negative cosine curve or a positive sine or negative sine? Some are going to be easier in determining the phase shift, so we want to really be cautious or careful about what we pick because some answers are a little bit more obvious than others. So that'll determine the phase shift. The phase shift will be the last value that we fill in, and then we'll add a positive or negative reflection to our sine or cosine curve depending on what the value is that we choose. Okay, that was a really quick overview of what we're doing here. Hopefully you guys saw some of these examples last year in Algebra 2, but we're looking at maybe slightly trickier graphs than what you would have seen last year. So let's work through this together. Again, you guys are going to need to show all of your work if you want full credit on this assignment and also on the test. So let's start by setting up our templates. So this is step number 1, and I'm just going to label it like that. Y is equal to a blank for the amplitude, and we need a cosine curve here. So we're going to leave a blank for the frequency. Because we're going to be in radians for all of these, I'm going to leave it like that. X, and then I'm going to leave the blank there. I'm not going to fill in that plus or minus sign yet because I'm going to let the phase shift determine that. And then the last blank on the outside will be the vertical shift. I'm going to do the same thing for sine. blanks are all in the same places. The only thing that's going to differ between our sine and cosine curve is the phase shift. That's it. The amplitude, the frequency, the vertical shift should all be the same. So the only thing that's going to differ is the phase shift and whether or not we're using a reflection of cosine or sine. Alrighty, so let's move on. Step number 2, find the amplitude. So the amplitude, remember, half the height of the graph. There's different ways that we can find it. Here's what I would recommend. I really like to draw the line right down the middle of this curve that represents the sinusoidal axis. I think later on it's going to be a little bit easier to see where our graph has key points if I have that sinusoidal axis drawn in. Okay, in this case, I have the maximum and I have the sinusoidal axis. So the amplitude there is the distance from the sinusoidal axis to the maximum. So in this case, our amplitude is equal to 11 minus negative 13. Right? In this case, our amplitude is 24. So I'm going to put 24 in the blank where we would find amplitude. All right, I'm color coding this. You guys can go back and reference what step goes in what blank. Step number 3 is to find the sinusoidal axis. So in this case, that's pretty easy. We've already got it. The sinusoidal axis here is negative 13. Y is equal to negative 13 is the horizontal line. So when I go to fill in that blank for the sinusoidal axis, I'm going to make sure that it has minus 13 there so we can represent movement down 13. All right, step number 4 is where this gets a little bit tricky, and this is where we're going to see a lot of the work. So 4A, I'm going to do it on the side. I'm going to have to write a little bit smaller. The first thing we want to do is find the subinterval length. Okay, so let's see what we've got along the x-axis. We are given pi over 2 and 7 pi over 6. So pi over 2 to 7 pi over 6, that's our interval. And I want to know how many sections between key points there are between pi over 2 and 7 pi over 6. So here's where I'm going to plot all of the key points, because like I said, it's a lot easier to see once you've got those key points sort of dividing the sections there. That'll be enough. But between pi over 2 and 7 pi over 6, I have 1, 2 sections. A full curve is made up of 4 sections, okay? But I have 2 sections here. So the subinterval length is going to be 7 pi over 6 minus pi over 2 divided by the total number of sections here, which is 2. Sections between key points. Okay, I do need to find a common denominator here. That is going to be 6. So this is 7 pi over 6 minus 3 pi over 6, all divided by 2. So this is 4 pi over 6 all over 2. And that is going to give us pi over 3. So that's our subinterval length, but the subinterval length doesn't actually go into any of the blanks that we've got. So we move on to step 4b, and step 4b says find the period. So the period is going to be our subinterval length times 4. So in this case, our period is 4 pi over 3. Again, the period doesn't have a place in any of the blanks. So we go to step 4c, and 4c says we need to find the frequency. So the frequency is going to be equal to the period, to 2 pi divided by our period. The standard period over the period of our curve. So in this case, 2 pi over 4 pi over 3. All right, that's going to get us 6 pi's over 4 pi's. The pi's are going to cancel, and the 6 over 4 simplifies to 3 over 2. So that's our frequency here. Now we do have a blank for frequency. In both cases, sine and cosine, 3 over 2 goes on the outside right in front of x. All right, the very last thing is how we determine that phase shift. So we've got to think about the information that we're given. All right, let me pick a different color here. The phase shift. So what information are we given along the x-axis? Let's start at pi over 2 here. Okay, at pi over 2, we have a minimum for our curve. So if we think about what we know about cosine, negative cosine, sine, and negative sine, which of those starts at a minimum value? There's only one. Negative cosine starts at a minimum. So the first curve that I'm going to write the equation for is a reflection of cosine. So I'm going to make sure that we've put that negative sign in front of 24 in front of the amplitude. And then our phase shift is right pi over 2. So in order to reflect a movement right pi over 2, it goes in as minus pi over 2 on the inside of cosine. All right, I picked pi over 2 because we were given that value, something that was given to us already. Okay, now, the other value that we were given along the x-axis is 7 pi over 6. So if I had picked 7 pi over 6 instead, at 7 pi over 6, I'm going to make a note here. This is negative cosine. Okay, at 7 pi over 6, we have a maximum. So think about it. Between cosine, negative cosine, sine, and negative sine, which of those four curves starts at a maximum? There's only one, and that's our positive cosine curve. So if you didn't want to use pi over 2 as your phase shift, I could change this cosine curve to be positive cosine with a phase shift right 7 pi over 6 instead. So I get rid of the negative in front of the 24. If we use the phase shift 7 pi over 6, it's a positive cosine curve moved to the right 7 pi over 6, meaning minus 7 pi over 6 on the inside. All right, but the problem is we still need a sine curve. We need the equation for a sine curve. So what I've got to do is I've got to use the values along the x-axis and what I know about that sub-interval length in order to help me figure out one of the key points for sine or negative sine. So remember that we found that sub-interval length, it was pi over 3. So if I start at pi over 2 and I add a pi over 3, I get to this point here, this key point here. And that key point right there, that's going to be on the positive sine curve because sine starts at its sinusoidal axis and positive sine starts at the sinusoidal axis and moves up to a maximum. I know that this key point is going to represent a positive sine curve. So I just need to figure out what that phase shift is. We get that from taking pi over 2 sitting on the x-axis and adding the sub-interval length pi over 3. All right, common denominator here is going to be 6. So that point looks to be 5 pi over 6. Okay, so positive sign, right 5 pi over 6 means we're going to have minus 5 pi over 6 on the inside. And that is going to be one option for our sine curve. There are many different options I could have picked there. I could have chosen to pick this point instead. This point here, I would have subtracted pi over 3, subtracted one subinterval length, and then I would have made sure to represent that as a negative sine curve because that's the key point that starts at the sinusoidal axis and goes down to a minimum. Okay, potentially lots of questions here. I'm going to do one more example with you guys and then have you try a couple of on your own before I give you the answers. All right, number 2 on page 26 looks like this. So the first thing I'm going to do, step number 1, always set up the template and then we'll go from there. So y is equal to blank for the amplitude, cosine, blank for the frequency in radians, so I'm going to use x, blank for the phase shift, and then on the outside, the blank for the vertical shift. Make the same template for sine. Remember, we need a sine and cosine curve for each. You'll be asked to do that on your test as well. And now we move on to step number 2. Step number 2 says find the amplitude. So first thing I'm going to do is I'm going to draw my line for the sinusoidal axis. Make it a little straighter here. Okay, that's the line that divides the graph directly in half. And so different ways to find the amplitude here. Remember that the distance from a minimum to the sinusoidal axis is the amplitude. All right, so our amplitude is going to be 3 minus -3, which is 6 here. So I'm going to make sure that I fill in 6 in the blanks where the amplitude goes. All right, step number 3, we want to find that sinusoidal axis. Well, the sinusoidal axis here is given to us already. It's the line y is equal to 3, so we're going to represent that as +3 on the end of our functions in order to represent a movement up 3. All right, for A here, this is going to be the subinterval length. And then later on, we're going to use that subinterval length to potentially help us find the phase shift as well. So I'm going to take a look at my graph. I've been given 2 pieces of information along the x-axis. So we have 2 pi and -pi. And the question is, between 2 pi and -pi, how many intervals do we have between key points? We've got 2 there. I've marked them. So our subinterval length is going to be 2 pi minus -pi, all over the total number of intervals between, which is 2. So our subinterval length is 3 pi over 2. So we move on. 4b says find the period. We do that by taking the subinterval length and multiplying by 4. So our period is 6 pi. Then the last thing we can do is find the frequency. The frequency is going to be the standard period 2 pi divided by our curve's period, which is 6 pi. Pi's cancel. The 2 over 6 simplifies to 1/3. All right, so our frequency here is 1/3. That's going to go inside sine and cosine, but outside in front of the x. Okay, last step. Determine the phase shift. So what are we given here? Well, we're given along the x-axis a minimum, and then 2 pi sits at a maximum. So minimums and maximums relate to cosine, either reflection of cosine or positive cosine. So it doesn't matter which one you guys want to use. I'll just use 2 pi since it starts at a maximum and that's positive cosine. So I can leave the 6 positive for our cosine curve, and then a shift to the right 2 pi would be minus 2 pi on the inside there. All right, so that's my cosine curve. If I wanted to use -pi, that's fine as well. What I would do is we would have to make the 6 negative because it'd be a reflection, and then to the right, to the left pi would be plus pi if I wanted to write it like that. Okay, and use pi there. Okay, so either way, those 2 options work, but we need to talk about sine. So sine always starts on the sinusoidal axis, regardless of whether it's positive or negative sine. We need to figure out a point along our curve that sits on the sinusoidal axis. So I can find this point here, I could find this point here, I could find this point here, or this point here. It doesn't matter which one you choose. There are many different options that will get you to one of the correct answers. So take your pick as to which one you'd like. Let's do this one over here. I'll circle it. I'm going to find this point here. Okay, and there's a reason for that. I'll talk about it in a minute. Okay, so what do I know about getting to that point? Well, I know from my maximum that sits at 2 pi, I can go 1 sub-interval to get to that point there. So I need to add to 2 pi my subinterval length, which is 3 pi over 2. All right, so this point is going to be 2 pi plus 3 pi's over 2. Find a common denominator, and we're going to get 7 pi's over 2 here. All right, so this point sits at 7 pi over 2. That is a phase shift to the right 7 pi over 2. So when I represent that on the inside of my curve, right 7 pi over 2 means we're going to subtract 7 pi over 2. Now, I picked this point on purpose because I haven't demoed an example like this. At this point, we're sitting on the sinusoidal axis, but our curve is going down from there. So this is a reflection of sine. This is minus sine. So I need to put a negative in front of sine there in order to get that correct. All right, different options. There's our phase shifts. Here's what I want you guys to do. Pause the video, do numbers 3 and 4, and then I'm gonna put up some answers that are possible for 3 and 4, and then check your work and pop back into the Zoom if you missed any of those or have any questions that you'd like answered before you start in on the homework assignment on page 27. Okay, show all of your work, make sure you've got all the work shown there, but give it a try on your own before you look at the answers. Okay, possible answers for number 3. Cosine is in red, sine curves are in purple. Identify. Pause the video if you need to check to see if your answer is there. If it's not there, pop into the Zoom to check to see if your answer would also be an option. I'm going to switch to number 4. Possible answers for number 4. Cosine again in red, sine in purple. Take a second, check your answers. You can pause the video if you need more time to peruse the possible solutions. You only need one for cosine and one for sine. You don't need to list all of them. But let me know if you've got any questions on that. Like I said, this is one of the highest point count on your test type of questions, and you're going to get a couple of them. So make sure you're good on how to do those. And if you've got any questions, please ask.